Ever wondered what happens to the water after it goes down your drain? Today, we embark on an enlightening journey into the inner workings of wastewater treatment and drinking water production, a complex, chemistry driven process that secures our most precious resource, water. In the United States, each person uses an average of 150 gallons of water a day, a figure that reminds us that every drop we use becomes part of a much larger cycle of purification and renewal. At the heart of this journey lies a fundamental challenge. Not all water is created equal. Although approximately 71% of the Earth's surface is covered in water, only about 2.5% of it is fresh water fit for human use. This discrepancy compels scientists, engineers, and environmental stewards to continuously innovate and refine treatment processes. Our lesson today is more than about a few reactions and key terms. It is a story of transformation, responsibility, and the marvels of chemistry applied to real-world challenges. Central to wastewater treatment is a sequence of carefully orchestrated steps. Initially, water undergoes preliminary treatment, where large debris is removed. Imagine a giant strainer that prevents bulky objects from interfering with the process. Then, during primary treatment, solids settle out naturally, much like the way sediment gathers in a quiet pond. These early steps lay the groundwork for deeper chemical and biological transformations. As water moves into secondary treatment, a fascinating chemical dialogue unfolds. Biological processes driven by microbes break down organic matter. This stage is nature's own recycling team, demonstrating chemistry at its most efficient. But our journey does not end here. Advanced treatment steps further refine the water, targeting specific contaminants in ways that highlight the ingenuity of modern chemical engineering. Advanced oxidation processes, for instance, generate highly reactive hydroxyl radicals, which oxidize and neutralize lingering organic compounds. The production of drinking water introduces another layer of complexity. This process typically involves coagulation, a stage where chemicals are added to the water to form clumps of pollutants. These clumps, or coagulated particles, then settle during sedimentation. Imagine tiny balloons gathering together before being carefully removed. Once this occurs, the remaining water passes through a filtration stage that eliminates residual particles, leaving behind a product that is both safe and crystal clear. Finally, disinfection ensures that harmful microorganisms are eradicated, making the water completely suitable for consumption. While the science is undeniably captivating, the relevance of these processes is perhaps most apparent when we consider the environmental stakes. Wastewater treatment does more than clean water. It conserves a finite resource. With water scarcity looming as a global challenge, understanding these processes amplifies our appreciation for every drop saved. Environmental stewardship begins with knowledge. In schools across the nation, students dive into these topics with curiosity and determination, inspired to seek solutions for a planet in need of sustainable practices. Let us also acknowledge an innovative treatment method known as electrocoagulation. This process uses electrical currents to destabilize contaminants in wastewater, causing them to coagulate and be effectively removed. This method, along with many others we discussed, not only reflects the ingenuity of modern science, but also points to a future where technology and sustainability work hand in hand. Drawing on these insights, we see that the chemistry behind water treatment is both a tale of crisis and hope. The obstacles posed by contaminated water are formidable, yet the solutions born out of chemical principles and rigorous engineering have built an impressive framework that safeguards public health and preserves our environment. Remember, each chemical reaction in a water plant is not merely a step in a procedure. It is a carefully balanced act of science, ensuring that the water we use for drinking, cooking, and cleaning is as pure as nature intended. As we conclude this exploration, let the transformative nature of chemicals and processes remind you of the power of science. Understanding the science behind water treatment empowers us to make informed decisions about water conservation and environmental stewardship. Embrace this knowledge and join the movement to save our water. Every drop counts.